Today, we're going to talk about a hidden threat that's lurking deep inside our power grid. It's this invisible kind of electrical pollution that, honestly, thanks to the boom in AI and renewable energy, is becoming a really serious problem for our high-tech world. So let's jump right in.
To really get a sense of the scale here, just look at this number, 1,000 terawatt hours. I mean, that's just a mind-boggling amount of electricity. It's what global data centers are on track to be eating up by 2026. To put that in perspective, that's enough juice to power the entire country of Japan for a year. And the biggest reason for this crazy surge? You guessed it, the absolutely insatiable energy demands of AI.
So here's what we're going to cover. First, we'll look at the new challenge our grid is facing. Then we'll get into what exactly these supraharmonics are. After that, we'll dig into the surprisingly high cost of all this electrical noise, check out a breakthrough in filtering technology, see some real-world results, and then wrap up by talking about what it all means for the future of power quality. All right, first up, the massive energy thirst of AI. And you know, what's so interesting about this is that it's not just about building more power plants. It's really about the quality of the power they deliver and what happens to that power as it makes its way to all our devices.
Let's bring this down to a personal level. When you do a simple Google search, it uses a tiny amount of energy, about 0.3 watt-hours. But ask ChatGPT a question, that single query uses 2.9 watt-hours. That is nearly 10 times more. Now imagine that multiplied by billions of queries as AI gets built into everything we do. You can see how this puts a completely unprecedented strain on our entire electrical system.
So, all this new power-hungry tech creates a whole new kind of problem. And that brings us to the invisible villain of our story, supraharmonics.
To put it simply, supraharmonics are just high-frequency electrical disturbances. The best way to think about it is like static on your power line. They operate in a frequency range that our grid just was not designed to handle, and they basically pollute the clean, smooth flow of electricity that all of our sensitive electronics really need to work the way they're supposed to. So where is all this electrical static coming from? Well, you might be surprised. It's not some obscure industrial thing. It's actually being generated by the very technologies that define our modern lives. The solar inverters on our roofs, the fast chargers for our EVs, the power supplies in the massive data centers that run the cloud, and yep, even the LED lights in our own homes.
And herein lies the problem. Our regulations just haven't caught up. The current international standards for power quality, they have a huge blind spot. It's like a regulatory vacuum right in the frequency range where supraharmonics live. Our technology has just raced ahead of the rulebook, leaving this growing problem almost totally unmanaged.
Okay, so a little noise on our power lines. What's the big deal, right? Well, it turns out this invisible problem causes some very real, very tangible, and very expensive damage.
The impacts are actually pretty serious. This electrical noise leads directly to wasted energy, and that means higher electricity bills for everybody. It physically wears down critical, expensive equipment, which shortens its lifespan. It can interfere with sensitive devices in hospitals and labs, cause catastrophic failures in data centers, and can even mess with our utility meters, making them give false readings.
Here's a number that really puts it all into perspective. For a data center, just dealing with these supraharmonics can extend the life of its huge power cables by 4 times. We're talking going from 20,000 hours of use all the way to 80,000. I mean, that is a massive savings in replacement costs, and that's not even counting the benefit of avoiding crippling downtime. But how does it actually do this damage? Well, a lot of it just comes down to heat. There's this well-known rule in electronics called the 10 degrees Celsius doubling rule. Basically, it says that for every 10 degrees Celsius increase in temperature, the lifespan of an electronic component gets cut in half. Supraharmonics generate exactly this kind of extra heat in wires and circuits, literally cooking them from the inside out and making them fail way faster than they should. Okay, so we've got a growing, expensive, and mostly unregulated problem. That is the perfect recipe for innovation. And that brings us to a real breakthrough in how we filter out this electrical noise, a new evolution in how we defend the quality of our power.
The tech to fight this electrical noise has really gone through 3 generations. Way back in the 70s, we had these passive filters. They were huge, clunky, and broke down a lot. Then in the 90s, active power filters, or APFs, showed up. They were better, but still gigantic, expensive, and they guzzled power. And the real kicker, they were never designed to handle the high-frequency noise of supraharmonics, which brings us to today and a totally new approach that's built for this exact modern problem. And the difference between the old way and the new way is, well, it's staggering. Compared to the old active power filter, this new superfilter technology is a total game changer. It is 1/600th the size. Just look at those dimensions. It weighs 33 times less, and get this, it uses practically zero power to do its job, while the old APF tech could be drawing over 2,000 watts constantly just to run itself. You throw in a 15-year warranty, and it's pretty clear this is a major leap forward.
So the fundamental difference is in the approach. An active power filter is kind of like noise-canceling headphones for your electricity. It has to actively generate an opposite signal to cancel out the noise. It's a constant, energy-hungry fight. The superfilter is completely different. It uses a passive, patented circuit to simply and silently absorb the unwanted electrical energy. It's just a much more elegant and efficient solution.
So, the million-dollar question, does it actually work? Let's take a look at some real-world proof and the kind of impact this new technology is having.
Here we have a case study on a pretty common piece of industrial equipment. Before they installed the filter, the total harmonic distortion, which is just a fancy way of measuring all the electrical noise, was at 24%. That's some pretty dirty power. But after they installed the filter, look at that. It dropped all the way down to just 1.74%. I mean, that is a massive, massive reduction in noise.
So what did that actually mean in the real world? It meant a 92% reduction in that harmful electrical noise. And even more impressively, it led to a real, measurable energy saving of 9.3%. Think about that for a second. For any factory or business, cutting energy use by almost 10% on a major piece of equipment is a huge win, and they did it just by cleaning up the power it was using.
Now let's look at an even more critical situation, a data center's power supply. Before, the harmonic distortion was at an absolutely wild 77.5%. Afterwards, it dropped dramatically. Now, look at the power factor. That's basically an efficiency score for electricity, where 1.0 is a perfect A+. It went from a pretty mediocre 0.78 to a near-perfect 0.98. And what that meant was the system wasn't just wasting less energy, it was actually able to deliver way more clean, usable power to the servers that needed it.
What all these results tell us is that there's this whole invisible layer to our infrastructure that, for the most part, we've been completely neglecting. And that brings us to our final thought: why managing this layer is so incredibly critical for our future.
You see, tackling supraharmonics isn't just about fixing a bug in the system, it's about unlocking a whole new frontier for efficiency. When we clean up our power, we cut down on interference, we lower heat and slash cooling costs, we make our super expensive equipment last longer, and we can save a significant amount of energy across the board. This is a fundamental, crucial step in building a truly stable and sustainable digital infrastructure for the age of AI and everything that comes next. And that leaves us with one last question to chew on. We've just uncovered one invisible challenge that was hiding in plain sight, right there in our power lines. As our world keeps electrifying at a breakneck speed, it really makes you wonder, what other invisible challenges are out there just waiting for us to find and solve them?